in the last video, I solved one problem, but this is the general problem. General problem means we have taken a as any integer greater than 2. So the problem is like this: if a function fx is defined over 0, 1 by fx is given by this. What is this? 1 upon a raised to r minus 1, where 1 upon a raised to r less than x less than or equal to 1 upon a raised to r minus 1. What are the values of r? 1, 2, etc. What is a? Greater than 2. Integer greater than 2. Then show that 0 to 1 fx dx exists, first part, and is equal to a by 1 plus a. Two parts are there. So the function is defined like this. First we list the value of the function for particular cases 1, 2, etc. First part we prove that it is integrable. For that we use any property of integrable functions. Then we evaluate that integral. How fx is defined? Here f of x is like this. Take a is r is equal to 1. What do you get? It is 1. Fx becomes 1. R is 1. When 1 upon a less than x less than or equal to 1. Take r is equal to 2. Fx becomes 1 upon a raised to 2 minus 1. 1 upon a, when 1 upon a square less than x less than or equal to 1 upon a. It is 1 upon a square when 1 upon a cube. Now we take r is equal to 3. R is 3 gives 1 upon a square when 1 upon a raised to 3 less than x less than or equal to 1 upon a square, and so on. Now these are the values of fx. See how it is defined? Fx is defined like this. In the interval 1 upon a to 1, it is 1. 1 upon a square to 1 upon a equal to 1 upon a, it is 1 upon a, 1 upon a square, and so on. Now, why it is integrable? It is integrable because you have studied properties of integrable functions. Here, value of x increases. When value of x increases, fx also increases. Therefore, fx is increasing function here. Every monotonic function is integrable. Therefore, it is integrable. First reason. Second thing is, fx is discontinuous at these points. What are that? 1 upon a, 1 upon a square, 1 upon a cube, and so on. Why fx is discontinuous at 1 upon a? Because when for left hand limit we take the value of x, value of fx which is defined for less than a. Less than a. Here point is 1 upon a, less than 1 upon a. When x is less than 1 upon a, fx is 1. When x is greater than or equal to 1 upon a, fx becomes 1 upon a. So the two-sided limits are not equal. When do you say that function is continuous? If limit of the function is actual value of the function. Limit means left hand and right hand limit must be equal. They are not equal here. So fx is discontinuous at infinite number of points. Discontinuous at infinite number of points. 1 upon a, 1 upon a square, and so on. But this set has only one limit point, that is 0. Only one limit point. 0 is the limit point. Therefore, by property of integrable function, what is the property? If a function has infinite number of points of discontinuity, but that set of infinite discontinuity has only finite number of limit points, then it is integrable. Therefore, fx is integrable. First part, fx is integrable. Second part is we have to find out value of the integral. Integral 0 to 1 we have to find out. Correct? 0 to 1 fx dx is in the interval 0 to 1. It is limit n tends to infinity. N tends to infinity. 1 upon a to 1 fx dx plus 1 upon a fx dx plus 1 upon a cube to 1 upon a square fx dx plus so on 1 upon e raised to r minus 1 to 1 upon e raised to r fx dx plus so on. N number of terms to be taken and n tends to infinity. It is limit n tends to infinity, or I write like this, tends to infinity of this. Limit n tends to infinity of in 1 upon a to 1. How fx is defined? I have to refer this. In 1 upon a to 1, fx is defined as 1. So 1 upon a to 1 dx plus 1 upon a square to 1 upon a, in 1 upon a square to 1 upon a, 1 upon a dx, 1 upon a cube to 1 upon a square, it is 1 upon a square dx plus so on. Then you get 1 upon a raised to n minus 1 to 1 upon a raised to n fx dx and so on. Now we evaluate this. How do we evaluate? We have to simplify this. It is integration of 1 dx is x from 1 upon a to 1 plus what is integration of this 1 upon a into 1 dx, 1 upon a common, x from 1 upon a square to 1 upon a plus 1 upon a square constant here, again it becomes 1 dx only. Integration is x from 1 upon a cube to 1 upon a square plus so on tends to infinity. Therefore it is 1 minus 1 upon a plus, you know how to take the value of x when x is 1 minus value of x is 1 by a plus 1 upon a into 1 by a minus 1 by a square, 1 upon a square into 1 upon a square minus 1 upon a cube plus so on to infinity. I think every step is clear here. All of you forward these steps. I simplify only next remain simplification, that is 1 minus 1 upon a plus 1 upon a square minus 1 upon a cube 1 upon a raised to 4 1 upon a raised to 5 etc. to infinity. Now it is a standard series. It is sum to infinity of a GP. What is the first term? First term we denote by a is 1 and common ratio minus 1 by a. Follow this. It is first term is 1, common ratio minus 1 upon a. Now we apply the formula sum to infinity of a GP. What is sum to infinity of GP? S infinity is a by 1 minus r. This is the formula. So value of this is a is 1 divided by 1 minus 1 upon a. 1 plus 1 upon a, taking LCM you get a by 1 plus a. So value of the integral is a by 1 plus a. Very standard problem it is. It is repeatedly asked in many universities examination. So try to understand the problem. If you have any difficulties, you can ask at any time. Now let me take one more problem. It is exactly same, and I state the problem and leave that as the exercise. A function fx, problem is like this. A function fx over 0 1 is defined by fx is equal to, so the definition 1 upon 3 raised to n if 1 upon 3 raised to n plus 1 less than x less than or equal to 1 upon 3 raised to n. What are the values of n? N is 0, 1, 2 etc. And f0 is 0. show that f is integrable. F is integrable, and find integral 0 to 1 fx dx. Can you find any similarity between the last two problems and this one? In the first problem, it was 1 upon 2 raised to n, where 1 upon 2 raised to n plus 1 less than x less than or equal to 1 upon 2 raised to n. In the previous problem, it was 1 upon a raised to n minus 1. Correct? Let me verify. It was 1 upon a raised to r minus 1. So the problems are similar, and here you can write the answer directly. You can guess the answer also. What is the answer here? Answer is 1 divided by 1 minus 1 by 3. Answer. Because a is 3 here. A is 3. Therefore, it is 3 divided by 3 plus 1, 4. This is the answer. 3 by 4. So, you try this as exercise. The problem is exactly similar. You will get the solution. If you have any difficulties, then you can contact. Now, one more example I take. This is somewhat different here. To find the sum to infinity, it becomes a other standard series. Problem is a function fx is defined over 0 1 by f of x is, say how it is defined, minus 1 raised to r if 1 upon r plus 1 less than x less than 1 upon r. And what are the r values of r? R is 1, 2, 3 and so on. And f of 0 is 0. See, the problem is like this. Fx is defined like this, minus 1 raised to r. R it is smaller, less than this. F0 is 0. Problem is, show that f is integrable in 0 1. Find it. First part is, we have to prove that function is integrable. For that, I write the value of the function here, taking different values of r given here 1, 2, 3, etc. First, we write values of r. First is, take r is 1, fx is minus 1 if 1 upon 2 less than x less than 1, and it is plus 1 because r is 2 when 1 upon 3 less than x less than 1 upon 2. Again minus 1, taking r is 3 when 1 upon 4 less than x less than 1 upon 3, and so on. It is simple. You have to substitute only r value of r here. When r is 1, what is minus 1 raised to 1? 1 minus 1. So when r is 1, we get this. R is 2, r is 3, and so on. It continues like this. Now f of 0 is given as 0. Now, what is the reason why the function is integrable? Reason is this. You have studied many types of the integrable functions. Here, function is discontinuous at infinite number of points, 1 by 2, 1 by 3, 1 by 4, and so on. These are the points where the function is discontinuous. As in the previous example, why it is discontinuous at half? Because when it x is less than half minus 1, x is less than half plus 1, greater than half minus 1. Therefore, left hand limit is 1. right hand limit is minus 1, or the two-sided limits are different here. How it is defined? Less than half, x is less than half, 1. Left hand limit is 1. Greater than half, minus 1. Right hand limit is minus 1. So the two-sided limits are different, hence the function is discontinuous. What are the points of discontinuities? This is the set of points of discontinuities. But this set has only one limit point, that is 0. So by property of integrable functions, even though it has infinite discontinuities, this set has, that point of discontinuity has only one limit point. Therefore, function is integrable. First part is what? Function is integrable. Second part is find integral fx dx. Now I consider 0 to 1 fx dx. How it is defined? Limit n tends to infinity 1 upon n plus 1 to 1 upon n f of x dx. This fx is, integral is defined like this. Now I extend this or I expand this. It is limit n tends to infinity 1 upon 2 to 1 integral. Just a minute. Integral 1 upon 2 to 1 fx dx plus 1 upon 3 to 1 by 2 fx dx plus 1 upon 4 to 1 upon 3 fx dx plus so on. Finally we get 1 upon n plus 1 to 1 upon n fx dx plus. Now in 1 upon 2 1, how it is defined? It is therefore limit n tends to infinity 1 upon 2 to 1 minus 1 dx plus 1 upon 3 to 1 by 2 1 dx. 1 upon 2 to 1 upon 3 to 1 by 2, it is plus 1. Correct? Plus 1. Continue like this. Plus 1 by 4 to 1 by 3, again minus 1. Plus so on. Therefore it is, what is integration of minus 1 dx? It is minus x, or minus of x from half to 1 plus x from 1 by 3 to half minus x from 1 by 4 to 1 by 3 and plus so on. I think you followed this one. Minus here plus minus, alternate plus minus you will get. Minus 1, it is minus 1 plus half, correct? Minus 1 plus half. Plus 1 by 2 minus 1 by 3. Minus 1 by 3 plus 1 by 4. And next term will be plus 1 by 4 minus 1 by 5 and so on. Now you can write this, it tends to infinity. We have to write here. It is limit n tends to infinity of, limit n tends to infinity of, correct? Last one, it is minus 1 raised to n 1 upon n minus 1 upon n plus 1 plus minus 1 raised to n 1 upon n minus 1 upon n plus 1, because n is any integer here, maybe plus minus, depending on you will get here plus sign or minus sign. It is, we simplify this, it is minus 1, value of this is minus 1, limit n tends to infinity is common here, limit n tends to infinity, minus 1 plus 2 into, I take 2 common here, 2 into 1 minus 1 by 3 plus 1 by 4 minus 1 by 5 plus so on. so on. You will get minus 1 raised to n plus 1, 1 upon n, and so on. Correct? This is the value of the integral. We will simplify further. How to simplify? It is limit n tends to infinity, minus 1, take minus 2 common because we have to express this as a standard series. Series is this. We express this as log 1 plus x form. What is log 1 plus x? X minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus etc. to infinity. This is log 1 plus x. And this can be written in the form of log 1 plus x. For that, it is minus 1 minus 2 into minus 1 plus 1 by 3 minus 1 by 4 plus 1 by 5 etc. to infinity. So it is limit n tends to infinity, minus 1 minus 2 into what we get, minus 2 into say you make this plus 2 into 1 by 2, it is 1 by 2 minus 1 by 3 and so on. Next step is we take minus 1 common here, minus 1 common, so you get minus 2 into this. Now the next step important, to add and subtract 1 here, add 1 subtract 1 in this bracket, then it becomes a standard series because it is in the form of log of 1 plus x. Log of 1 plus x, here you refer that one, in place of x write 1, you will get this. So it is minus 1 minus 2 into log 2 minus 1. Simplifying we get this, it is 1 minus log 4. 1 minus log 4. You go through this. Next is only simplification here. Important thing is log 1 plus 6 form it is, and add 1 subtract 1 is important. And I think this is clear. I conclude here, and next video I consider next topic. Yes, thank you.